Fullstack developer at TD Securities. I work in finance in Java, some Node, and some front-end stuff in Angular. And like you guys, I started in a boot camp a few years ago, and the Functional Programmer Starter Kit is really kind of my experience going from understanding object-oriented and trying to understand what is this concept of functional programming. So as I'm sure most of you are aware, there's kind of an ongoing debate within the programming community of, should we be more object-oriented? Should it be more functional? Kind of this debate that you see at a very kind of high level. And what I found when I was trying to learn about functional programming was that everything that was out there was kind of this abstract, kind of unrelatable, people arguing about very abstract ideas that when I needed to implement functional, or if I wanted to kind of learn more about functional programming, it didn't really relate to what I was doing. So I kind of saw that talks broke down into three things. So there was kind of the abstract thinkers in the debates. That was like the majority of things, which are really smart people, John Resig, other people who talk in terms, very functional inertia and other type of functional composition, but they don't really tell you, if you're starting out, what does that really mean? And kind of the next, so they looked kind of something like this, right? It's kind of very authoritarian. They had this very powerful feeling. And after you hear one of their talks, it's like you feel so inspired, but then 2 days later you realize I haven't actually coded anything that matches what I just saw, right? So I didn't want FPSK to be something like that. And so the next group was kind of the libraries and the frameworks, and those I think are a little more useful, right? Because then okay, this framework is going to be dead in 6 months or a year. I really shouldn't spend my time on that. But that still doesn't get you to kind of hands on the keyboard. You're implementing functional concepts. So what I saw of implementation, it was all very contrived. You had stuff like, this is a for loop, and that's imperative, or that's object-oriented. And this is a map function, and that means that's functional. But does that really get you any closer to writing, pure functions and stuff like that? I don't think so. So the concepts I want to talk about are kind of three basic things, which are immutability, which has to do with how you handle your data, composition, which is how you build things into larger objects, and finally promises, which is how do you handle asynchronous behavior. But before I go into that, I want to go into kind of why functional. Basically, the idea of why should I care about functional? Why shouldn't I just continue kind of the object-oriented way of how I do things? And I think it really has to do with kind of understanding just a little bit of the history of programming, of how we got to where we are in object-oriented. So before you look at something like this. This is procedural. And this was kind of the standard way of doing things. We did things in subroutines. You can see there's a ton of nested logic. And essentially, code went from the top of a file, it read all the way to the bottom. And it was crazy. I mean, nobody wants to kind of go through this after a programmer has written something like this, right? No one wants to have to be the refactor of code like this. And so a guy came along, Alan Kay, this guy, and he invented something called small talk. And essentially, he said that object-oriented and programming should really be based off of kind of organisms. He had this kind of weird idea that it's kind of like biology, that when you create an object, it instantiates, and you can replicate that thing that you've created, this object, and that can be used for other areas of your code base. So you don't have to rewrite like you had to do with routines of rewriting the same code. So he really kind of revolutionized how people thought about programming, because no longer you could dry up your code considerably, right? You write one thing, and you guys understand object-oriented. It allows you to kind of save time and have drier code. So what functional really is about is kind of taking a similar concept of how do you compose something? How do you make something that's stable, that like Alan Kay tried to do with object-oriented, but kind of taking it to the next level. So what functional essentially says is that every function takes an input and that maps to an output. And that's all the function should do, is that it takes x, and x will map to y every single time. So if you ran that function 1,000 times, the same behavior will happen. And of course, every piece of code wants to do that. But what happens in object-oriented, and you'll see often, is that because object-oriented tries to do many things at the same time, you hold state of something, you call a function that does multiple behaviors. Essentially, you start having spooky action at a distance, basically, where one time something else happens than expected, you run a function 1,000 times, and eventually it starts to degrade. The state that you had originally, that you held, is completely different from what it is after the 500th time that you've run something. So functional programming is about really composing things so that you take one function, it does one thing, and then you build that up to be something bigger. If you take nothing else from this, just know that kind of building your functions in that way of doing kind of single responsibility of where a function has an input and that maps to an output, of trying to get that every single time. Not trying to do a function where within a function it calls something else. You always want it to return a value. So that's kind of the basis of functional programming. So this is what I have used as an example. I created a very basic site. Certainly could use some love, some CSS love. But essentially just a CRUD, create, read, update, delete. And I did it kind of in an object-oriented approach, and I did it in a functional approach. So I have some code snippets that I'll kind of run through of that to give you guys an idea of examples of functional programming and examples of immutability. That's kind of where we'll start with it. So what is immutability, right? Immutability is essentially the concept that once you set a value to an object, those two are forever tied together, so you can't change it. And if you learn programming through a bootcamp, or how most people learn programming, we all learn kind of the mutable way. In JavaScript, you set an object, you can change that object however you want. You decide that that object is a different type. Now it's an array, now it's a string. You can really do whatever you want. And it's awesome when you're starting out, right? Because it has the flexibility. You make a mistake or you want something to be different, you can kind of have that flexibility to do whatever you want. The problem really comes when you try and scale that application, right? You now want 10, 20, 100 developers. It becomes much more difficult to have any certainty that what you set today is actually going to be what that value is tomorrow or next week or next year, right? And that's what we're all obviously hoping for in our applications, is that they can scale. So this is kind of the difference, just to illustrate. I use IMMUTABLE.js. It's Facebook's immutable library and what they kind of use in React. But this is essentially the difference between immutable and mutable. So immutable, you have drone.engine, you can change. Drone, you can even change the type if you want. But in an immutable world, once you set this object, it's forever tied to it. So when you do drone.set, you're essentially returning a completely new object. And you would set that to a new value. And it seems like it's just a small thing, right? It's just like, okay, I have a new value, but who really cares? But it kind of goes back to the idea that of certainty in our application. You've replaced something that was once flexible but uncertain with something that forever of the lifespan of your application will always be the same. So taking this example of update drone, right? It's a function. It takes in another function. You have variable drone equals engine, x9000 or whatever. So drone factory, takes in drone, and then if you console log drone, does anyone know what drone would be? The answer really is it's impossible to know in a mutable world, right? Because you have no idea what drone factory has just done to that variable. Anything could have happened. And what you do today, as I said, could be very different how someone customizes your code a month from now, and they've decided that, well, drone factory is also going to call this other function and have an event listener. So you see how the complexity kind of increases, and that's going to lead to uncertainty. But when you put in an immutable library, you essentially have the certainty that this function, update drone, or console log, will always return to you the exact same value. So you can know that, okay, I have this function now, and I can use that as a building block, instead of having to worry about, well, is it this function that's the problem, or was it another piece of my building blocks that's really causing the issue? So Again, yeah, it's all about kind of building something that's certain. The last point I'll make, this is just another code snippet from it, is to always do, if you're trying to implement immutable without any other functional concepts, which is how I recommend if you're interested in kind of learning about functional programming, is to always do it at the lowest level. Wherever you're interacting with your API or wherever the model layer is, do it there so that you don't have to do type checks throughout your application, seeing, well, is this an immutable object, or is this an object that is mutable? Just know that everything that enters into your kind of client-side application is already an immutable object. So that's kind of the basis of functional programming, the idea that how you handle data. Everything else, I'd say, is kind of an extension or a benefit, but I'd say that's probably the most important concept in immutable, in functional programming. Kind of the other key piece of it is composition. And whether you're doing object-oriented composition or you're doing functional composition, everything is using composition, right? Everything you're using, no one's creating anything that's monolithic where it's just like one huge piece of code, like they used to do in procedural, right? You always have something that's kind of the basis of your building block. In functional programming, it's obviously the function. So let's take a look at something like this. So this is a data parser. So you get something back from the server. It's not exactly how you like it, so you want to do a change. This would be an imperative or a kind of more object-oriented way of looking at it. You're just modifying an object, and you're changing it. Essentially, this is basically throwaway code, right? You use this one time. It doesn't have much reusability. It doesn't have much flexibility. With functional composition, we're essentially trying to build very small little building blocks that we're going to chain together that can do some powerful stuff. So let's take a look at this piece of code. It's a little more complex, and this is, I think, where people kind of get turned off from functional programming and functional composition, because there is a little more of a learning curve, but we can definitely break this down. So function.setTable, that's essentially we're just setting a table in Angular of we get something back from the server that's object.data, and variable immutable data is essentially just changing it to an immutable structure. So that's just immutable.js doing something for us. And then vm.rowCollection, that's just essentially setting it on scope. And then this is really where kind of the complexity arises. We have immutable data .map vm.parse data. So essentially we're saying we have some data set, we're going to apply the map function to it, and we want that data to be something different, right? So here we have vm.parse data, and that takes r.compose, which is going to take an anonymous function and a modify name. So I'll go into that piece a little more, but I think if you guys understand just the first piece, which is just simply you're setting a table, and you're changing it to an immutable object, and you're applying the map function. We can kind of dive into how we're going to compose this vm.parse data. So here we have four functions, right? The first is an anonymous function. If you've ever, when you're using map, you usually pass in an anonymous function, right? That's pretty standard. And that's essentially what's called every time that map is called. So format object, this is where kind of a little more complexity arises, is that we're putting in an immutable object. We're going to say model.name. It's the same example that we were using before, but we're essentially saying input, whatever that input is, plus the name that we're getting back from the server. That's what we want to use. So that's just how we're changing the input. And then we're going to return an immutable object to whatever function that's going to apply that. So here, format object is essentially just that one piece of code that's going to take one object and it will change it to whatever, the best drone ever or whatever. And then we have modify name. So we're going to take format object and the original. So that's essentially what is going to be the input. So format object is the function we have here, and this is going to be passed into format object. So what r.partial does is it's partial application. And that's essentially, if I have a function that has maybe 3 inputs, but I only want to pass in 2 right now, I can do r.partial, so it essentially will allow for one of my inputs to be dynamic and the other two to be set for everything. So what we really did was we essentially passed this in and we separated it out from, now we can pass in anything we want, right? We could make this the best drone ever or whatever our input is, and format object is kind of kept clean. The idea really here is that all these are very easily kind of micro pieces that you can take out. So that if you wanted to change that anonymous function to maybe a logger or something that saves the state, or if you wanted to change format object so that it's something completely, you're parsing it in a completely different way, you have these little pieces that now can be kind of interchanged rather than a clunk of code that saves state. Everything here is stateless. And finally, we have our anonymous function, and we have modify name. So modify name was just what we said of format object being passed this, the original. And then we have the anonymous function, which is going to be applied on every single object. All right? Really, the two things that are difficult here are r.partial and r.compose. We've kind of gone over what partial application is. And compose is essentially, it's similar, but it's essentially passing in these two functions. That's kind of the basis of functional composition. It's that, as I said, you have small pieces. You can reuse those pieces throughout your code base. And this is something that's extremely easy to test, right? Anonymous, you're essentially just saying, is the input that I passed in going to be the thing that I return? Format object is just, is the input appended to the original drone name? So everything becomes these little testable pieces. And that's going to make, as you scale an application, so much easier, because you don't have to worry that one piece of your code is the problem, or that it's saving state. So this is just kind of all of it put together of set table and how set table would be called. So the final kind of topic I want to talk about is promises. And that's essentially how do you handle asynchronous behavior? I think definitely some of you guys are familiar with what promises are, of how it's just a different way of handling a callback, right? But kind of what people generally think of a promise is it's just like a cleaner way to handle a callback. But really it's about control flow. It's about how do you handle asynchronous behavior in which you don't have to always be aware of where you are currently in the application. So with callbacks, I'll use an example from Node to kind of illustrate that. But with callbacks, you're always having to make sure that your callback is in the right place at the right time. And at times there isn't even a physical representation within the system. So you take this very kind of basic example of you're reading a file. While that file is being read and before your callback is called, there's no physical representation that is returned in the system. And what promises do is they essentially send you back a wrapped function. They're essentially a monad, but they send you back a wrapped function that has data within it. But it's really the function that's always being passed back to you. So that's kind of the subtle differences about promises versus callbacks. Probably the smallest area of functional programming that kind of is relevant. But the idea that there's always a physical representation being that function that's passed back to you is kind of what makes promises very different from callbacks. So those are the three topics that I hope that you get away from it. I have some more kind of detailed written up articles that I'd hope can kind of take you through if you're converting this code base that's in object-oriented and a few other concepts of functional programming. But I think if you can implement immutable data structures, if you can start to make these small functions that basically compose together, and if you simply use a promise library, you're going to see so many issues that you face with state, so many issues that you face with trying to track down, well, did this call this function, and why is this object not having the correct state that I thought it did? So many of those issues are going to disappear in your code base. And it's going to become something that's far more about reading clean code rather than kind of digging into trying to find the problem. So I think that's kind of what functional programming presents. It's still in its very early stages of kind of being implemented and the front end. But I'd love to answer any questions you guys had about it or any follow-up. Thank you. Awesome. And yeah, you can